Good morning. Hello, everyone, and welcome back to the channel. You are joining me for part 6 of our AI Enterprise Architecture series. And today we'll dive into one of the most important but often overlooked layer, the AI information architecture layer. If AI is the brain, then data is the fuel. And just like a library needs to organize books, catalog knowledge, and ensure the right people can access the right resources, businesses need to carefully manage how data is collected, stored, secured, and shared. In this episode, I'll break down the principles, the core components, challenges, and strategic value of AI information architecture, all in a simple language with relatable examples so you can see how it fits into the bigger AI enterprise puzzle. So let's start and discover how organizing data the right way can turn AI into a truly trusted and powerful assets. As seen earlier in the series, this is the overall agenda, and we are now at AI information architecture phase. The agenda within this is as shown in the screen. So let's start the journey. This is your host, Savit Vitthal Salian. Namaskar and welcome. AI information architecture defines the structure, processes, and governance mechanism that manage data across its life cycle, from acquisitions and preparation to usage, monitoring, and retirement. In traditional enterprise architecture, that's data architecture, focuses on structured database and warehouses. In AI information architecture, it expands the scope to include unstructured and multi-modal data, could be text, image, video, or from IoT. It includes data lineage, provenance, and integrity. It includes ethical dimensions such as fairness, privacy, and accountability. It also includes continuous monitoring of data quality to prevent biases and drift. It is the fuel supply of the AI enterprise architecture, ensuring that the right data reaches the right model at the right time, safely and responsibly. In traditional enterprise architecture, data architecture focuses on the structured database and warehouses. In AI, it is the fuel supply chain of AI EA, ensuring that the right data reaches the right model at the right time, safely and responsibly. From storage to flow, it shifts the board's focus from static data warehouse to a dynamic supply chain of data feeding AIs. From a strategic asset perspective, it treats data as the fuel of competitiveness, ensuring business outcomes are powered by trusted insights. From a governance imperative perspective, it embeds privacy, ethics, and compliance into every step of the data flow, reducing regulatory and reputational risk. From operational resilience perspective, it ensures availability, quality and timeliness of data so AI models can perform reliably at scale. From a risk versus value balance perspective, well, poorly managed data flows could create biases, errors, and compliance exposures. Whereas well managed flows would create trustworthy AI outputs. From a future readiness perspective, it builds a scalable, safe, and responsible data pipeline that supports AI innovation across the enterprise. AI information architecture is about how data is collected, organized, stored, and delivered so the AI system can use it effectively. In short, it's the blueprint for managing data, making sure the right people get the right data in the right format and at the right time. From a top level perspective, it's a strategic enabler. From a strategic enablement perspective, it ensures data is treated as an enterprise asset, powering both decision making and AI outcome. From a trust and governance perspective, it provides transparency, security, and compliance, thus reducing regulatory and reputational risk. From an operational efficiency perspective, it streamlines access and quality of data, thus preventing duplications, silos, and any costly inefficiencies. From a value creation perspective, it equips the AI models and business leaders with timely, accurate data that directly supports strategy and KPIs. From a risk control perspective, it embeds data protection, privacy, and ethical safeguards, thus ensuring the enterprise maintains its license to operate. From a future readiness perspective, it builds the foundation for scalability, enabling AI adoption across the enterprise without any data chaos. Now, why it matters? Well, AI is only as good as the data it learns from. Now, if data is messy, scattered, or biased, AI won't work properly. Good information architecture ensures quality, accessibility, security, and trust. Now, let's go with an example. Imagine a big public library. Books come from many authors and publishers. Similarly, in AI, data comes from sensors, apps, social media, or transactions. That's your data source. Then, books are sorted by subjects, authors, and categories. So, you can find them. In AI, data is structured, labeled, and tagged for easy use. Now, that's data organization. Then, books are stored safely on shelves. Similarly, in AI, data lives in database, data lakes, or warehouses. That's your database aspect. Some books can be borrowed, some only can be read inside. And for the rare ones, you need special permission. Similarly, in AI, access is controlled. Who can view, who can edit, or who can use certain data. That's your governance and access control. Now, readers use the books for study or for fun. Similarly, AI models and analysts use the data. It could be for training, predictions, or providing any insights. That's your AI models and people. Key takeaways? Well, AI information architecture is like a library system for data. Without cataloging, books are impossible to find. Without storage, they could get damaged or lost. Without rules, chaos could break out. Similarly, without a good information architecture, AI won't get the clean, organized, and trusted data it needs to deliver value. So, AI information architecture is the blueprint that turns data into strategic asset. It ensures the right people and AI models get the right data in the right format and at the right time. When done well, it drives trust, compliance, and efficiency. If done poorly, it could create silos, create risks, and there is a wastage of the investment the organization has done. For the organization, this is what makes the difference between AI being a liability and AI being a scalable engine, bringing value and competitive advantage to the table. In summary, think of AI information architecture like a library. Books are your data collected from many sources. Cataloging organizes them so you can find the right one, just like structuring and labeling data. Shelves are the database where information is stored safely. Library rules decide who can borrow which books, just like governance and access control. And readers are the AI model and people who use the information to learn and take decisions. Without a good library systems, books are lost potentially in chaos. And without information architecture, similarly, AI can't work effectively. I hope this helped with certain context. Let's look at principles of AI information architecture. Well, it has few components, namely in this conversation we have five major ones. The first is data as an enterprise asset. Well, you need to treat data as a strategic resource, not just a technical input. You need to value data from with the same rigor as financial or physical assets. Then you need to follow the FAIR principle. Here, data must be findable, accessible, interoperable, and reusable. So that's FAIR principle. The AI information architecture operationalize these principles. The next is lineage and provenance. Each AI prediction should be traceable back to its data source. Need to ensure that you are preventing a black box output. The next is being trustworthy. You need to prioritize data quality, fairness, privacy, and compliance. You need to build stakeholder confidence in AI driven outcome. That's the objective of being trustworthy. Next is life cycle management. Information must be managed right from acquisition, use, archiving, and retirement. It includes retention schedules which are aligned with regulations. So, to make AI useful and trustworthy, the way we manage the data flow, some core principles need to be followed. First is the data quality first. Now, AI is only as good as the data it learns from. Example, cooking with fresh vegetables makes a tasty meal. A rotten one ruins it. The second is accessibility and availability. The right people and AI systems should get the right data at the right time. Example, a library where books are easy to find are not hidden in storage. The third aspect is consistency and standardization. Data should follow common formats and rules across the organization. Example, street address written in the same styles. So, email always arrives correctly. So, that's consistency and standardization. Next is governance and security by design. Data must follow rules, permissions, and privacy requirements. Example, in a library, rare books are in special sections and only staffs can handle it. The next is transparency and explainability. Now, users should know where the data has come from and how it's used. Example, a food package with a clear ingredient label. That helps understand the transparency and explainability aspect. The last one is scalability and flexibility. Or rather, we have one more to go. In scalability and flexibility, the data system should grow as the business grows. Example, expanding a pantry to store more food as the family gets bigger. And the last one is ethics and fairness aspect. Data should not reinforce bias or harm people. Example, a teacher treating every student fairly when grading. Now, to make AI truly useful and trustworthy, the way we manage data must follow some non negotiable principles. It starts with data quality first because poor data means poor decisions. Second, accessibility and availability, ensuring the right people and systems get the right data at the right time. Third, consistency and standardization, which is to prevent fragmentation and waste. Fourth principle, governance and security by design, which is embedding compliance and protection from the outset, not as an afterthought or a plugin. The fifth principle is transparency and explainability, which is to ensure we can see how decisions were made. This is to build confidence with regulators, customers, and employees. The sixth principle is scalability and flexibility, which is to keep us future ready. So, data systems grow with the business. And the last, of course, is the ethics and the fairness aspect, which is to ensure AI reflects our values, not just our capabilities. For the organization, these principles are not technical checkboxes. They are the foundation of trust, resilience, and sustainable value in every AI investments. Core components of AI information architecture. Data source and acquisition. This has five subcomponents: relational database, ERP, CRM systems, and financial ledgers. This comes under the structured data aspect. Then you have emails, call transcripts, PDFs, documents. These are unstructured data. Images, audio, video, sensor feeds are multi-model data. Open data sets, third party providers or web scraping comes under external data. Data generated to address scarcity or privacy concerns are categorized as synthetic data. Enterprise must establish clear policies for data sourcing, licensing, and ownership. That's the first aspect. Then you have data preparation and curation. Do note these are the core components of AI infrastructure information architecture. So under data preparation and curation, you have five subcomponents, which is from a data preparation pipeline, which includes removing duplicates or correcting errors. This is the cleansing part. Then you have standardizing formats and units, which is normalization. Do note the difference. When you remove duplicates and correct errors, that's cleansing. But when you standardize formats and units, that's normalization. Then you do annotation and labeling, which is human or automated tagging for supervised learning. So you tag it whether it is from what source, which is automated or human. Then you have augmentation, which is expanding the data sets with synthetic variations. And finally, you have bias detection, which is identifying imbalances across genders, ethnicity, or geography. Data ops practice integrates preparation with continuous AI pipelines. The third aspect from the core competency components perspective is data storage and management. AI workload demands flexible storage architecture. To store raw, unstructured, and multimodal data at scale, we use data lakes. For structured, query optimized storage for analytics, we have data warehouses. When it is hybrid approach, whether it's Databricks or Snowflakes, combining both, that's lake house. Semantic structures enabling reasoning or relationship is known as knowledge graphs. Whereas catalogs describing data lineage, schema, and ownership is metadata repository. So do note here, When you're storing raw, unstructured, multimodal data, that's data lakes. Whereas when it is hybrid approach, where you're combining data lake and data warehouse, that's called as lake houses. Moving on, the next is data governance and stewardship. Governance defines rules, responsibilities, and controls around data uses. We have chief data officers, data stewards, custodians. These are categorized as stewardship roles. Then you have access control, consent management, data sharing agreements. That is your policies. Then you have classification of data, which could be public, confidential, sensitive, or regulated. So that's data classification. Now, every data access logged for compliance, whether it could be for GDPR or DPTP, when it is for compliance, that is actually having an audit trail. Governance ensures AI model consume only authorized, high quality, and compliant data. The next aspect in this is data, that is quality and trustworthiness. Key dimensions of AI data quality includes the data be free of errors, that's primary. It avoids missing values, that's completeness. It is up to date for real time AI, that is, has the timeliness aspects covered. It's uniform across the system, so it is consistent, and it is representative without any biases. So that's the fairness dimension. Monitoring tools like Evidently AI and Great Expectation validates these metrics continuously. The next is data security and privacy aspect. AI information architecture must embed security and privacy by design and not as an afterthought, which is at encryption should be at not just at rest, should be in transit and increasingly in use. Now we have the homomorphic encryption. Anyone interested in homomorphic encryption, there's a video that I've created on this specific topic. People can look at it if that interests you. The next is the differential privacy, which is you need to add noise to protect individual identities. That's maintaining a differential privacy. Then you have federated learning. You need to train models without moving the sensitive data. So that's federated learning. From a zero trust data access perspective, the data should be context aware and with least privilege access. These controls align with the regulation, which could be GDPR, HIPAA, or India's DPTP Act requirement. The next aspect is data lifecycle management. The acquisition, it ensures licensing and compliance. The active use aspect, it's about monitoring, versioning, and quality checks. The archival aspect, it's retained only as long as needed or as per regulations. The deletion and the retirement aspect, it's about securely erase or anonymize the data. This prevents data hoarding, which increases the risk without adding any value. Revisiting core components of AI information architecture. Well, AI information architecture is about how data is managed for AI. Its main components are data source, where the data is coming from, Example, in a library, books comes from authors and publishers. In AI, data comes from apps, sensors, websites, social media, or transactions. The second component is data collection and ingestion, which is how the data is gathered and fed into the system. Example, the library buys or receives new books and logs them in. Similarly, in AI, data pipeline pulls information from different systems into storage. That's data collection and ingestion. Then it's data storage, where the data is kept safely. Example, books are stored on shelves in libraries. Similarly, in AI, data lives in database, warehouses, or data lakes. Then we have data organization and cataloging, which is structuring and labeling data for ease of use. Example, library books are catalogued by subject, by author, and categories. Similarly, in AI, data is cleaned, labeled, and tagged for modern training. Then we have data governance and security, which is about rules about who can access or modify the data. Example, rare books are kept in the locked section with special rules. Similarly, in AI, access control, encryption, and compliance ensures data safety. Then we have data processing and preparation, which is about making raw data usable. Example in this is a librarian repairing torn books or sorting damaged ones before shelving back. Similarly, in AI, data is transformed, normalized, and made ready for the models. The next is metadata and lineage, which is the information about the data source and history. That's metadata and lineage. Example, a book has a title page, author name, and edition number. In AI, the metadata tracks where the data came from and how it was changed. So that's metadata and lineage. The next is delivery and access channel, which is how the data is shared with users or the AI models. Example, library readers borrow books through a checkout desk. Similarly, in AI, APIs, dashboards, query tools deliver the data to apps and related AI systems. We take a day-to-day example and go back to the library. The data source is the author and the books. The collection is library acquiring new books. The shelves holding them safely is the storage. Catalogs and the indexes are organization. Borrowing rules and restricted access is your governance. Books repaired, sorted, or rebounded is your processing. Details of your authors, edition, publisher details is your metadata. Readers borrowing books through a system is your delivery part. So, just like a library needs these parts to function, AI also needs these core data components to provide a clean, secure, and useful information. The core component of AI information architecture are like the part of a library system, from book acquisition to cataloging to storage to protection and delivery. Now, without these, the library becomes chaotic, and without them, in similar sense, AI, the data becomes unusable, insecure, or just untrustworthy. So, if we summarize again with all the examples that we have learned on this, AI information architecture is like running a library. Books comes from author, that's your data source. New books are logged in, that's your data collection. Shelves hold them safely, that's your storage. Catalogs help you find them, that's organization. Rare books are locked away, that's your governance and security. Damaged books are repaired before shelving, that's data processing. Each book shows its author and edition. That's your metadata. And finally, readers borrow books through a single checkout desk. That's data delivery. Together, these part keeps both the library and the AI data organized, safe, and useful. Ethical dimensions of AI information architecture. AI systems are only as ethical as the data they consume. Key considerations that need to be factored in could be bias mitigation, explainability, consent and control, or accountability. Let's go into each. When you say bias mitigation, example is credit risk models trained on biased data may unfairly reject minorities. That's an example of being of AI system which is having a bias. Application must show which data points influence the prediction. That's explainability. If you are not, then you have a challenge here. Users should have the right over their data, an option to opt in or opt out, and data portability. That's having consent and control in place. And data lineage ensures that harmful outcome can be traced to specific data set, which means you need to have a data lineage, a clear data lineage, which is important part of the accountability aspect. AI information architecture thus acts as a moral compass, ensuring AI systems remain human centric. So, when we design how data are collected, stored, and used for AI, we must think about ethics, fairness, privacy, accountability, and transparency. Let's look at the ethical dimensions. When we say privacy, it's about protecting people's personal data. Example, just like a doctor keeps your medical record private, AI systems must safeguard personal details. The next dimension is being fair and unbiased, which is about ensuring data doesn't discriminate. You need to be aware of the bias aspect of it. Example, a teacher grading all students fairly without favoritism. Similarly, AI must also treat everyone equally, not favoring one group over the others. So that's fairness and bias aspect. From a transparency perspective, it's about explaining how the data is used and where it has come from. Example, food packaging shows the ingredient, so you know what you are eating. Similarly, in AI, users should know why the data is collected and how the decisions are made. Now that's transparency aspect. From an accountability perspective, it's about having someone responsible for the data use. Example, in a library, the librarian is accountable for managing borrowed books. In AI, organizations must take responsibility for data misuse or errors. That's accountability. From a security perspective, it's about protecting data from leaks, hacks, or unauthorized use. Example, locking your house at night. Without locks, anyone can walk in. Similarly, in AI, encryption and access control keeps the data safe. From a consent and rights perspective, people must agree to how their data is used. Example, before taking your photo, a friend asks permission. Similarly, in AI, user should have the control over whether their data is to be used or not. So that's consent and rights. Let's try to understand with an example going back to our library with ethics. Well, imagine a library that not only organizes books but also follow ethical rules. Some books are kept confidential. Those are privacy. Every reader has equal access to those books. There is no favoritism. Now that's the fairness aspect. The catalog shows exactly what books are available and their sources, which is transparency. The librarian is responsible for lost or damaged books. That's the accountability aspect. Rare books are locked in special rooms. That's the security aspect. Readers choose which books they want. No one forces them. That's the consent aspect. In the same way, in AI information architecture must ensure data is private, fair, transparent, secure, accountable, and based on consent. So, AI systems are only as ethical as the data they consume. Now, if the data is biased, incomplete, or poorly governed, the AI will reflect those flaws in its decision. That is why AI information architecture is more than a technical framework, it's a moral compass. By embedding principles of fairness, transparency, and accountability into the way data is collected, managed, and shared, we ensure AI remains human centric and aligned with our values. For the organization, this is not about algorithms. It is about trust, reputation, and responsibility. A strong information architecture safeguards stakeholders, builds confidence, and ensures that AI enhances society rather than undermining it. So, in simple terms, it is the governance foundation that keeps AI both useful and ethical. The key takeaway, The ethical dimension of AI information architecture are about doing the right thing with data. Just like a library that respects privacy, treats everyone fairly, and secures rare books, AI systems must handle information in ways that builds trust, fairness, and responsibilities. So if I summarize this conversation, thinking of AI or think about AI ethics like running a responsible library. Privacy means keeping certain books like medical journals confidential. Fairness means every reader has equal access. There is no favoritism. Transparency is the catalog that shows what's available and where it came from. Accountability is the librarian who takes responsibility if books go missing. Security is locking away rare volumes. And consent means readers choose which book they borrow. In the same way, AI must handle data ethically with privacy, fairness, transparency, accountability, security, and respect for user rights. Let's take some sector specific case studies. BFSI, the credit risk scoring model. The challenge is historical lending data encoded systemic biases. We might have that challenge here. The solution for this to is introduce fairness aware pre-processing or data lineage tracking and enabling regular audits. When you come to healthcare, about AI diagnostic trained on medical imaging. The challenge here is data privacy under HIPAA and DPDP. The solution is federated learning architecture need to be enabled, ensuring no raw data leaves the hospital premises. In telecom, well, AI detecting anomalies in 5G network slice. Well, petabyte scale real time data streams. That's volume. Solution here is Lakehouse or Kafka pipelines or real time data validation. Now, here the concept of 5G network slice. If you're interested to know about this, there's a separate video on this topic on 5G network slice on my channel. You can have a look into that. Come to e commerce. This is where you have personalized recommendation. The challenge is it requires user profiling and requires a consent under GDPR. Solution, you need to have a consent tracking metadata. In addition, you need to anonymize the clickstream storage aspect. Now let's look at challenges. You have quite a few. You have data silos, biases and fairness issue, data volume explosion, regulatory complexity, or high cost on data preparation. Well, different business unit hoard data, blocking enterprise wide AI. It requires data democratization strategy. So that's the data silos aspect. Historical inequities encoded into the training data is a major challenge. It requires ongoing monitoring to detect and correct it. That's the bias and the fairness issue aspect. The IoT, social media, multimodal source would overwhelm your storage and processing. It requires scalable lakehouse architecture. So that's the challenge from a data volume explosion perspective. Then you have challenges of cross-border compliance, whether it is GDPR in EU, DPDP in India, HIPAA in US healthcare, and so on. And you are required to enforce data localization and retention policies. So that's the challenge from a regulatory complexity perspective. Then enabling annotation, labeling, these often cause or consume a lot of budget when it comes to the AI projects. One of the major contributor to the cost. So that's your high cost of data preparation. That's one of the major challenges that every organization is facing today. Moving on, you have challenges in terms of messy and scattered data, data silos that we discussed, poor data quality, privacy and risk aspect, and so on. If I go a little deeper or take a round on that, data comes from many places. It could be apps, sensors, social media, and is often inconsistent. Example, a library book scattered in a box. Some are with missing pages and some there is no catalog. So that's the messy and the scattered data challenge. Different department keeps their own data, making it hard to share. Does this sound a bell? Yes, this is a challenge today. Example, one library branch refuses to share the books with others. So that's the challenge of data silos. Incomplete, outdated, or biased data lead to bad AI outcome. That is a library with books full of typos and misinformation. That's poor data quality aspect. Sensitive data may be leaked or misused. Example, anyone can walk into a library private record room and copy the files. That's the challenge from privacy and security risk. Data are stored in different formats, making integration difficult. Example, some books use English titles, others use only numbers, making them impossible to find consistently. That's lack of standardization. Now, as data grows, systems struggle to store and process it. Example, a small library suddenly receives a million new books but has no shelves to hold them. That's your scalability issue. Now, AI decisions are hard to track back or trace back to the data, the original data. Example, a reader gets the wrong book, but the librarian can't explain how it happened. That's the explainability challenge that we have. If I want to put it up as an analogy, let's go back to the library example. Imagine a public library with serious problems. The books are scattered everywhere. That's messy data. Branches don't share resources. That's data silos. Many books are full of errors. That's poor data quality. Rare books aren't locked up. That's weak security. Catalogs are inconsistent across sections. That is lack of standardization. New donations overwhelm the shelf space. That's scalability issue. Now, readers can't understand why they got a certain recommendation. That's the challenge of limited explainability. In the same way, AI information architecture faces challenge that can make AI unreliable, unsafe, or just unfair. The key takeaway, the challenges AI information architecture are like running a badly managed library. Scattered books, poor quality, no sharing, weak security, inconsistent cataloging, overcrowding, and confusing recommendation. Now, to make AI trustworthy, these issues must be solved with better organization, governance, and scalability. See, if I want to summarize this whole discussion, we say imagine a library in chaos. Books scattered in boxes, some full of errors, and no clear catalog. Each branch keeps its own collection and won't share. While rare books aren't locked up, new donations flood in, but there is no shelf to hold them, and readers don't understand why they got certain recommendation. That's why AI information architecture struggles with messy data, siloed data, poor quality data, weak security, no standards, scalability issues, and lack of explainability. Hence, unless fixed, AI becomes unreliable, unsafe, and unfair. Let's look at some of the best practices in AI information architecture space. You adapt FAIR principle, which is ensuring discoverability, accessibility, and reusability. You can embed privacy by design. This differential privacy, federated learning, or anonymization. From an automate data ops perspective, you need to ensure the continuous pipeline for cleansing, monitoring, and validation. Implement knowledge graphs, which is enhancing semantic reasoning and explainability aspect. You monitor bias and drifts. Use tools for fairness, stability, and data quality audits. Then you establish a strong stewardship. You assign a CDO, stewards, and custodians. These are some of the best practices that can be used. There could be more, but these are something which comes on the top. Strategic value of AI information architecture. AI information architecture is the bridge between the raw data and the business value. You ensure data trustworthiness, thus preventing flawed AI outcomes. You enable compliance with global privacy regulations. You power explainability. It powers explainability and transparencies. It provides the semantic richness for advanced reasoning. It is not just about managing the information, but about ensuring information's integrity, making AI output reliable, ethical, and business aligned. AI information architecture isn't just about organizing data, it's about turning data into a strategic asset for the organization. Now, here's why it matters. Clean, organized data helps AI provide accurate insights. Just like a well organized library where you always find the right book when you need it. So that's better decisions. Now, with the right data in the right place, teams build AI solutions faster. They can build it faster. Example, a chef with prepped ingredients can cook faster and more creatively. So that's for faster innovation. So this is why it matters. Moving on, a solid data structure supports enterprise wide AI growth. Example, a house built with strong foundation can easily add new floors. So that's the scalability aspect. Now, next is ethical and secure data handling builds user trust and keeps the regulator happy. Similarly, like a restaurant with transparent hygiene practices would attract loyal customers. So that's trust and compliance. Now, data driven insights help outperforms competitors. Yes, so that's the competitive advantage aspect. Like a shop that knows exactly what its customers like will always serve them better than one guessing. If I take an example and going back to our example of the library, imagine two cities with library. City A, the books are scattered, unorganized, and some are missing. Readers would waste hours finding what they need. City B, a library is neatly organized, every book is catalogued, and rare ones are secured. Now, readers get what they need instantly and hence trust the system. So, the second city thrives just like organizations with stronger AI information architecture in place. The key takeaway, if I put it that way, would be the strategic value of AI information architecture is that it transforms the raw data into powerful, reliable, and trusted source for decision making, innovation, compliance, and competitive advantage. Just like a well run library empowers a city with knowledge, good AI information architecture empowers the organization with insight and trust. So, summarizing, think of AI information architecture like a library. In one city, the books are scattered, uncatalogued, and full of errors, and readers thereby waste hours to find what they need. Whereas the other, the library is neatly organized, every book is catalogued, rare ones are secured, and readers can quickly find what they need. Hence, the second city thrives because knowledge is accessible, can be trusted, and useful. That's the strategic value of AI information architecture. It turns raw, messy data into a reliable, secure, and trusted asset that fuels better decisions, faster innovation, and compliance and competitive advantage is built on. Let's now try to look at some of the tools. So, for data integration and ETL tools, which extracts, transforms, and load data from multiple sources into a unified format for AI model. This ensures consistency, standardization, and quality of input data. So you have tools like Informatica, Talent, Apache, Nifi. Similarly, data cataloging and metadata management, which acts as an inventory of data assets, showing lineage, ownership, and usage, supporting findability, transparency, and compliance. We have tools like Colibra, Allotation, Apache Atlas. Now, to ensure a single version of truth for critical business data like customers, product, and transaction, or to prevent duplication and inconsistency that could bias AI models, we have tools like Informatica, MDM, IBM Infosphere, or Relito. This is the master data management tools. Now, to provide frameworks for data ownership, policies, and compliance control, which helps enforce privacy by design and audit readiness for AI systems, we have tools like Colibra, OneTrust, or Big ID. This comes under the data governance platform space. Now, to monitor and cleanse the data to ensure accuracy, completeness, and reliability, or to catch errors and anomalies before they impact the AI models, we have tools like Talent Data Quality, Atacama, SAS Data Management. This comes under the data quality and profiling tools. Now, to trace where data comes from and how it has been transformed, or ensure critical for which is critical for auditability, trust, and regulatory reporting, we have tools such as Manta, Apache Atlas, or Microsoft Preview. These comes under the data lineage and provenance aspect. To enforce access control, encryption, masking, and anonymization, which is to ensure that sensitive data is protected while still usable for AI training, we have tools such as Varonis, Immuta, Privacra, which comes under the data security and the privacy aspect. Next, to provide scalable storage for both structured and unstructured data, which acts as a backbone repository feeding the AI systems. You have tools such as Snowflakes, Databricks, Lakehouse, Google BigQuery, Amazon Redshifts. This comes under the data lakes and warehouse aspect. To allow unified data access without physically moving it, which is useful for faster, more flexible AI experimentation and prototyping. You have tools such as Denodo, Typico Data Virtualization. This comes under the data virtualization aspect of it. Next, to provide data observability to detect drift, anomalies, or downtime, which is to ensure data pipeline and AI systems remain resilient and trustworthy. You have the tools such as Monte Carlo, Data Band, or Big Eye. This comes under the observability and monitoring aspect. If I look at the stack with the tools, for cloud and compute, we have AWS, Azure, GCP, Kubernetes, VMware. For storage, we have HDFS, S3, Azure Data Lake Storage. For networking, we have Kafka or Apache Pulsar. For technology layer, for the ML framework, we have TensorFlow, PyTorch, or ONNX. For orchestration, we have Kubeflow, MLflow, Airflow. For ML Ops, we have Data Robot, SageMaker, Vertex AI. When it comes to application layer, when it comes to integration middleware, we have MuleSoft, Apigee, WS2. For API management, we have Kong, Postman, Azure API management. For business applications with embedded AI, we have Salesforce Einstein, SAP Leonardo, or ServiceNow AI. So, AI information architecture, this is the fuel supply chain, ensuring that the right data reaches the right model at the right time. If I summarize it, we have data integration and ETL says, which we discussed. So to summarize this, this is a screen. You can take a screenshot of this and use it against your reference and see which are the tools that could help you in your space. Now, from a business architecture layer perspective, for strategy and KPI, you have balance scorecard or OKRs. For process automation, you have UiPath, Blue Prism. For decision intelligence, you have Power BI, Tableau, QuickSense, and AI. And when you cut across for governance, risk, and security, For governance, you have COBIT, you have ISO 38500, NIST AI RMF. For security, you have 27001 ISO, NIST CSF, Zero Trust Tool. For risk and compliance perspective, you have the GRC platform. Could be RSA, Archer, ServiceNow, GRC, or metric stream. The key takeaway, the strategic value of AI information architecture is that it transforms the raw data into a powerful, reliable, and trusted source for decision making, innovation, compliance, and provide a competitive advantage. Just like a well run library empowers the city with knowledge, good AI information architecture empowers organization with insight and trust. In summary, AI information architecture provides the data backbone of AI enterprise architecture. It ensures that the data is collected, curated, stored, secured, and governed responsibly. It integrates FAIR principles, data lifecycle management, ethical safeguards, and compliance alignment. Without this layer, AI system risks being biased, opaque, and non-compliant. With this layer in place, enterprise can scale AI responsibly while maintaining trust and regulatory adherence. The next layer is the AI business architecture. It will explore how AI capabilities are aligned with organization models, value streams, and strategic objective. The AI business architecture ensures that the AI becomes a driver of enterprise transformation and not just a technical experiment. I hope this part of the series has helped you in some way. If you think this has brought in value to your table, do like and subscribe the channel so that the next video, once uploaded, you get a notification. Yes, do share it with your colleagues, students, friends who you think can derive a value out of this video. The idea behind all these videos are to share across the community. No one is left behind. AI is the hot topic for the town. Every organization, every staff has been asked to scale up. The challenge is from where? I've tried to create that base here in small ways. If it can help in, it would be appreciated if you share. Concluding, thank you very much for the time that you have invested till now. We have completed the part 6 and we will be moving to the part 7 of AI business architecture. This is your host, Savit Vittal Salian, thanking you. Namaskar.